Hey crew, Catlin here, lesson 9 of your homework, second page, back of the front. Vending machines got 5 colors, white, green, red, blue, and yellow, of gumballs and an equal chance of dispensing each. Second machine has 4 different animal-shaped rubber bands, lion, elephant, horse, and alligator, and an equal chance of dispensing each of those. If you buy one item from each machine, what's the probability that we're going to get a yellow gumball and a lion band? All right, so let's see here. Probability. It probably would be a good idea to find out how many is going to be in the sample space. So on the first vending machine, okay, on machine 1, how many outcomes could happen? Well, there's 1, 2, 3, 4, 5 colors, so 5. On machine 2, how many outcomes could happen on machine 2? You got 4 different animal shapes. So that tells me there's going to be 20 outcomes. And let's look and see if the question is one where we need to count something in the sample space or if there's just an obvious amount of them. What's the probability of getting a yellow gumball and a lion band? There's only one way to get yellow and lion. One way out of the 20 total. So pretty easy on that one. Number 2, the numbers 1 through 10 are put in a bag. The numbers 5 through 14 are put in another bag. When you pick one number from each bag, what is the probability you get the same number? This one is a lot like the warm-up that we had on Wednesday. All right, so let's do how many total outcomes, and then we'll make a list of the ways that we want it to happen. I don't think we need the sample space for this. So for the first draw, for draw number 1, how many outcomes are there in numbers 1 through 10? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers. Okay. Draw 2, you got to be a little careful with this one because on draw 2, 5 through 14, it really does help to list those. 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. A lot of kids will do 14 minus 5 and say there's 9, but if you count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's actually 10. So there are 100 ways for this to take place. We're looking for, out of those 100 numbers that you can pull, combinations of numbers that you can pull, what's the probability that you get the same number? Okay. Now remember, the second bag only has 5 through 14, so it's impossible to get 1, 1. It's impossible to get 2, 2, 3, 3, 4, 4. But you could get 5, 5, right? You could get 6, 6. You could get 7, 7. You could get 8, 8, 9, 9. And they both have the number 10 in them. So you could get all the way up to there, but you have to stop there because that first bag doesn't go past 11, although the second bag does. So if you count out how many of these there are, 1, 2, 3, 4, 5, 6, we've got a 6 in 100 chance, or about a 6% chance of getting both the same number out of these 100 possibilities. All right, moving on to number 3. Roll a standard number cube and flip a quarter is the first thing, and we got to write the sample space and tell how many outcomes. Okay, so let's do for part A. Let's do a simple list. I think list would be okay for this one. So part A, I'll do right here, and let's list it out. We got to list the sample space and then tell how many are in it. So I could roll a 1, flip a heads, roll a 2 heads, 3 heads, 4 heads, 5 heads, 6 heads. And then I could do the same things with tails. 1, 2 tails, 3 tails, 4 tails, 5 tails, 6 tails. If I'm rolling the number cube, I can get 1 through 6. If I'm flipping the quarter, I can get heads or tails. There's 6 times 2 or 12 outcomes. All right, so for the other one, let's do B down here. Let's do for this one, this will be easy. Let's do a quick tree diagram. So months, January, February, March, April, May, June, July, August, September, October, November, December, and stemming from each of them 2 years, either 2020 or 2025. So 2 coming out of each. Boom, 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 and 20 and 25, 20 and 25, 20 or 2025, 20 or 2025, so on and so forth. It'd take me a second to finish. As I finish, let's ponder about how many would be inside of this. I had 12 different months, and I had 2 different years. So 12 times 2 gives me 24 outcomes. 12 months, 2 different years, 12 times 2, 24 different ways, as you see here in the listed sample space. On the graph, we have the area of a square compared to its perimeter. So let's draw a square. Okay, the first one is the perimeter. So if I've got 20, that means that this is the square that we're talking about. Okay, this is this square. 5 plus 5 plus 5 plus 5 is a perimeter of 20, and 5 times 5 is an area of 25 square units. You can see why 20 and 25 is the connection that they have. Same thing would happen with this one. That would be a 4 by 4 by 4 by 4. So we got to add some. Let's do a simple square. Let's do a 3 by 3 square. That's easy enough, right? What's a 3 by 3 by 3 square's perimeter? Well, its perimeter would be 3 plus 3 plus 3 plus 3, or 3 times 4. That would be 12 units. And its area would be 3 times 3, which is 9 units squared. So the ordered pair over here, since the x is the perimeter, that would be 12, and the y is the area, 9 would fall right here. So that dot would be there. We have added 1. We need 1 more. I don't know. Let's go smaller. It looks like we got more space down here. So let's do a 2 by 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 2 2 by 2 by 2 by 2. So 2 by 2 square. We would have a perimeter of 2 plus 2 plus 2 plus 2, which is 8. So we'd have a perimeter of 8 units, and then we would have an area of 2 times 2, which is 4 units squared, 4 units that would go inside. And if we plot that over here, perimeter is on the x-axis, so we go over 8, and then area of 4, we go up 4. All right, we've plotted 2 more, and let's answer the questions. Is there a proportional relationship between the area and perimeter of a square? No, there is not a proportional relationship. How do I know this? I know this because the graph is not straight and through origin. In fact, if you were to graph it properly, it would have a nice little curvature to it, something like this. Not straight, definitely curved, not going through the origin, although it does go through the origin. So not straight is the main thing there. It would actually go through the origin, but you can't have a square with 0 length sides, so impossible. Let's look at the next page of your homework on the next video. Stay tuned, children.